Hello, Matt G for IYT here. Today we're looking at the full license mock examination number 1, version 1.6. We've reached question 28, which is a nice simple one, and it reads, which mode of signals is demodulated with a ratio detector? So which mode of signals is demodulated with a ratio detector? Is it FM, SSB, AM or CW? Well, as always, the full license manual has us covered, and it has a great chapter on receivers that we've been looking at quite heavily with the last few questions, and it does cover all of this, of course, as well. So let's run through. Well, you may recall that SSB and CW both typically use a product detector. And it turns out that the product detector used for SSB can be tuned slightly off, and it makes a great detector for CW as well. AM, hopefully with AM you may have seen just this idea of envelope detection with a simple diode and a capacitor for detecting the envelope of an AM signal. Obviously, in your 1,500 quid icon, it's going to be a bit more complicated than that. But fundamentally, we can use the technique of envelope detection for AM. I'm not going to try and draw out. Am I going to try and draw the whole of envelope? I am. I'm going to try and draw the whole of envelope really badly, and that leaves us with FM for our answer. Well, let's take a quick look at what a ratio detector is and try and develop a bit of intuition around this. So it is covered, of course, in the full license manual, and there is actually a good description of how this works, but this is the ratio detector here, and we effectively have this tuned circuit, which the whole idea behind the ratio detector is we use the incoming RF, and we make this tuned circuit resonate, and we've got this tuned circuit coupled with this inductor here, and when this tuned circuit is resonating, what we should see is the voltage at A and the voltage at B should be equal. And with FM, you have a carrier, and that carrier deviates from where it normally is to as it's modulated, because we're modulating the frequency. And so as the frequency goes up, it's going to cause this tuned circuit to come out of resonance, and effectively the phase angles of the signals that develop at A and B become out of sync, and you end up with a different voltage between A and B. So normally, when the carrier is right in the middle, they're the same. As the signal deviates, they will change. And you can see here we've got this phasor diagram represents it, where at below resonance you get a greater vector for point A and a smaller vector for point B, and what that ends up doing is we have this kind of this slice of this slope here, and what we do is as the output voltage goes up or goes down following this slope based on those phase angles, and it is to do with the ratio of those angles to each other. It determines how much that changes. So it's a really quick whistle-stop tour of the ratio detector. There's a good section here about FM detection. The full manual does cover that really well, and that is our answer for A. Let's skip down to the answer, see if we've got that. We can see for 28 it is, of course, answer A. Thank you very much. I'll catch you for the next one.